Am I on? I think I'm on. Okay, this is me going live for the first time in ever. So this will be exciting. I'm going to be starting a new project this in the near future, and one of the things that I need to do is to have a text editor in the project. Doesn't matter what the project is. It's going to contain an embedded text editor. So what I want to do is to code that text editor myself, and we are going to try and do this in C. Um, full disclosure, I'm a .NET developer. I do everything in C sharp. I think in C sharp. Everything is C sharp for me. So me and the garbage collector are like this. Um, Generics are my life, and this is going to be tough. Why am I doing this in C? I don't know, because I wanted a challenge. See, I thought about doing this in Rust. I tried doing some Rust stuff. And you know what? To be blatantly honest, I didn't much like the experience. It was too convoluted. Um, and not that Rust programming is bad. I couldn't get into it. So anyway, C, I did some stuff in C++ in the 90s before I even knew what objects were. So essentially, I've done C in high school a little bit. So we're gonna do C because, well, I'll show you why. I tried to do a project in C++. I mean, that's the alternative, right? C++. So yeah, I'll just show this to you. Uh, what am I doing? My back is really hurting today too. So that sucks. Anyway. Oh, look at this. That's fun. There's some test stuff. Okay, open folder. Let me get this. So I made a Tetris analyzer in C++. Yeah, of course I trust myself. I just cloned it. New Linux box here. I don't care. We're just looking at the code right now. So this is my foray into C++ programming, and it was okay. I mean, I had some. It basically this lets you play a game of Tetris on a Nintendo with a capture card. It would analyze the video and it basically create a robot announcer, keep track of your statistics and criticize you when you're not doing so hot and praise you when you're doing well. Anyway, it was a fun little project. I originally wrote it in .NET and then I decided I wanted more speed and so I did C++. Anyway, this is um, so you've got uh, data streams here. So yeah, I used abstract classes, um, virtual classes, I guess they're called in C++. I don't even know the terminology. They're abstract classes in .NET, whatever. Actually, this is an interface, but C++ doesn't have interfaces, so I made a virtual base class. Anyway, and then you do stuff like this, and so there we go. This is clearly not in a ready production state, but whatever. Um, and so Uh, yeah, so what I did was I decided I was going to use shared pointers everywhere. And so I made this sort of type def for a shared pointer. And then I realized that was stupid. And so some of these files are using the the template and some are not. Um, Let me go to the image here. So here, actually, I was using the my templated type def here. Anyway, it's just a lot of gobbledygook. Look at this. Look at this. Return standard makes shared image, makes shared mat, and it's just to me this was just overbearing. Um, and then not to mention I didn't understand all the nine different kinds of constructors. So yeah, I wasn't going to continue uh, doing anything in C++ for a while. So anyway, I wanted to do something in C. So let's try and do something in C. I really want to do something in C. Um, and so let's do this. I'm going to use, I'm going to try and use C Lion because it just went free for use, for personal use. And so we'll try and give this a go. And then, oh yeah, this was my test. I'm going to close this, close the project, and we're gonna make it. Whoa, come on, let's go. We're gonna make a new project. C executable. Okay, so what language do I want to use? Oh, they don't even give you the C89 standard. They give you C90. From what I understand, C11 is kind of the most well used, well supported thing that still allows you to do threading. So we'll just use C11. I'm pretty sure it won't matter for quite some time in this project. Let's just start this. How do I make a new folder? Okay, we're gonna call this rope. We'll lowercase it. Here we go, rope. Okay, so this, yeah, we're making a rope. What's a rope? Well, we're gonna look at the Wikipedia page for a rope. Okay, this is gonna go maximize. Come on, maximize. You can do this. There we go. So there we go. And I think if I hit Control F5, this should execute and hello world. Perfect. Okay, so we're in. We're in. We're halfway there. Everything is working. If I do this, yeah, that closes it. This is kind of cool because it's got this Zen mode. This, and then I can like increase this and not know at all where I am or what I'm doing. I think I'm going to use that. Anyway, let's get to what I'm actually making. So from what I understand, to make a text editor, again, like I said, this text editor is going to be embedded inside of a larger project that I do want to work on at some point, but for now, we'll just pretend we know what we're doing. And the reason we're going with a rope data structure, and I think that's probably big enough. Okay, so from what I understand, the rope data structure is a very nice data structure to use for text editors. You don't want to use giant strings. I hear that Emacs uses some gap thing. There's a gap down here. Is there a gap? Uh, References, gap buffer. So Emacs uses this, and I was looking at this a little bit. It's pretty straightforward, but it's also very simplistic. And I don't know. I don't. Yeah, if I'm gonna do something, I'm gonna do things the complicated way. So anyway, we're gonna make a rope, and I guess what a rope is, I don't really know what a rope is, so we're gonna find out. This is fantastic. This is apparently a rope. Whoa, that's big. So it's a data structure to hold a string. So all on the leaf nodes, you have the actual string. Hello, my name is Simon, and these all get concatenated together. But the idea is that the number, from what I understand, the number is the length of the the left node. So, so hello is six characters. I guess they're using underscore for space. And then my space is 3 characters. So because the hello is on the left, it's 6. So this is keeping track of the length. But if you're not a leaf node and you have child nodes, what you're going to do is you're going to be the weight of all your children. But if, see, this doesn't make any sense. So maybe I should just read the Wikipedia article, because this is the weight of the, that's 6 and 6. Those two things are together. But this 6 is really this 2 and 4 added together. This 2 is because this is 2. And I guess as you go up the hierarchy, you start combining things. Anyway, apparently this data structure, you can split strings and concatenate strings really easily. So this is going to be this is what we're going to do. So let's learn about this. So we got a rope or a cord. Okay, fantastic. I don't even know why this thing is called a rope. Okay, it's composed of smaller strings, is used to efficiently store and manipulate longer strings or entire texts. And that's why it's good for text editors, apparently. Okay, so for example, a text editing program may use a rope. Fantastic. Okay, let's make that even bigger. Okay, it's a binary tree. We can see that. It holds a string of manageable size and length. Okay, each node further up the tree holds the sum of the length of all the leaves in its left subtree. The sum of the lengths of all the leaves in its left subtree. Okay, so that makes sense. That's why we're seeing here, this is the left subtree, and this is the sum of all the leaves. 2 and 4 is 6. Okay, so then this is 9 because the 6 and the 3, this 6 and this 3 are the leaf nodes. So to figure out the weight of a node, you look at the left tree and you go all the way down to the leaf nodes and you add them all up. It's basically the length of the string. And so using this data structure, it looks like length is an O1 operation. You just get the length of the string immediately. So that's fun. Okay. Left subtree stores the first part of the string. The right subtree stores the second part of the string, and a node's weight is the length of the first part. Okay, fantastic. Okay, yeah, now we need operations. So we've got strings, and the nodes are constant immutable objects, allowing for some copy on write behavior. Oh, fun. Leaf nodes are usually implemented as basic fixed length strings with a reference count. Attached for deallocation when no longer needed. Although other garbage collection methods can be used as well. Well, we don't have any garbage collection, so that's fantastic. Okay, what are the operations? Collect leaves. Okay, n is length of the rope. That is the weight of the root node. That's fine. Create a stack S and a list L. Oh, this is just this is just the algorithm to collect the leaves. So that's one thing we're gonna have to do. And this, you know what? I hate Python. Python sucks. Everyone's using Python because they think it's is this Python? It sure looks like Python, but no, this is private final. Just, oh, no, this is Java. That's why I hate looking at it. Here's the .NET developer saying how much he hates Java. Well, they're almost basically the same thing. Okay, so collect leaves. That's one operation. Rebalance. Collect the set of leaves L and rebuild a tree from the bottom up. Oh, that's interesting. is balanced. Okay, I guess conceivably, if you're if you keep on tacking at the end, which text editors kind of would do, you keep putting text on the rightmost node, you're basically going to get a linked list at the end of the day if you don't go back and do some other things. So I guess yeah, you have to rebalance the tree, or else you're going to lose a lot of its efficiencies. Okay, so yeah, so that's what rebalance. We're going to have to rebalance it. Good, good. Okay, insert. Of course, we have to insert string s beginning at position I to form a new string. Woohoo! Time complexity O log of n. Because it's a binary tree, that makes sense. Um, yeah, and that's cool because if you're going to insert into just a regular string, uh, you're going to have to go to the ith position, and you're going to have to, yeah, basically allocate more memory and copy the old string into the new string with all the three pieces, the left part, your new part, and your right part, and you're basically going to end up at an ON operation. So log of n for inserting, that's good, that's good. Index, we want to just find an index, and that's log n as well. Now in a regular string, that would be O of 1, so that's not sure how often you're doing that though. Okay, so that's that, and then we're going to concatenate two. So if we have two ropes, we can concatenate them into one rope. That's kind of what we want to do. And then we want to split a rope. Man, this is going to be mind-boggling. I didn't start off with an easy thing, did I? That's craziness. That gap thing might might looking pretty good right now. Okay, anyway, it doesn't matter. Delete the substring to form a new string, of course. Okay, so yeah, we're gonna just take these one at a time and report. What the heck is report? To report the string. Oh, this is a substring kind of a thing? Output the string. Yeah, this is, oh, interesting. J plus log of n. I guess, yeah, this better just be a special case of the regular one, or rather, the regular collect leaves must be a special case of this one. In that case, I is 0 and j is the length. Oh, see, that's kind of stupid. J is collecting O of n. Collecting must be O of n. They don't say. Where's O of n? They don't say. Why? Oh, they don't even have anything on the rebalance either. Oh, well, gee, thanks. Anyway, yeah, okay. So if j is like basically near the end of the string, it's going to be O of n. But whatever. Oh, here we go. We got this staring at me right in the face here. Iterate, concatenate. What? Amortize. Oh, what are you talking about? Oh no, that's concatenate. Iterate over. Yeah, well, of course it's got to be O of n. You got to iterate over everything. Okay, but they claim amortized. So on average, your concatenations will be O of 1. Well, that's kind of cool. All right. Okay, so I think this is good. Faster insertion and deletion of text on which operations have time collect. Yeah, of course. O of n, ropes do not require ON extra memory. I mean, I'm not really concerned about memory. This is 2025. The disadvantages. more space needed. There's a trade-off between how much of the total memory is such overhead and how long pieces of data are being processed as string. The strings in examples are unrealistically short. Well, yeah. The overhead is always O of n, but the constant could be made arbitrarily small. Okay. Nobody really cares. Uh, Table compares. Okay, so that's it. Okay, so here we go. Let's do this. Okay, so if I go like this, now we're here. Uh, okay, let me make a new C source file. No, I'm doing C. Okay, I'm going to make something called a rope. And here we go. Let's do this. This is so exciting. I what is this? No, I'm not putting that. Okay. Okay, so here we go. Um, we're gonna need a node of some kind. A node. So I'm not doing this. I'm not doing header files. I'm gonna try a Unity build. We'll see how that goes. Uh, okay. Um, yeah, and plus I don't know what I'm doing here, so I know that we do this. We need a node. Maybe we should call this a rope node. And yeah, okay. It's telling me next. Yes and no. I need a left. Are you gonna be smart enough to give me a right? There we go. So we've got the left node and the right node. And I think, what do I need here? Yeah, it just, okay, so there needs to be I guess we're just gonna say an int length and a string data. And yes, I've got this all messed up here. Okay, so those are my properties on the rope node. That's fun. Oh, is this right? Do I see? I don't even know. I don't know C. Do I do this? Rope node. There we go. That's what I got. Okay, and then I can, if I go back to my main, can I include rope dot C? And can I make a rope node? Perfect. No, let's go. How do you do this here? I'm so lost. I think you go dot, don't you? Dot left equals null. Dot right equals null. Dot length equals say 3, and dot data equals yo. Can I do that? Maybe I should do that. No, I'll do that. There we go. Does that make sense? I don't know what I'm doing. I have no clue. Okay, and then your favorite number is, we'll do this, and let's see if we can't do that. Can I do that? Does that work? Okay, it works. I know what I'm doing, apparently. Okay, awesome. Okay, so there's my rope node, and I can use it, and that's fantastic, and I'm happy about it. Let's close this, and we'll go to my rope node. Okay, so now I need, what are my operations? Well, let's create a new one. Rope node. Look at that. I gotta say, um, Sea Lion is nice for giving me what I want. So we're going to create a new rope node. No, wait a second. I don't want a new rope node. I want a new rope. Well, I guess, wait a second. A rope is nothing but its node, its root node. I don't need to hold anything else. Yeah, okay. We'll just do this. And its data and its length. And we'll say return. Look at that, mallex size of rope node. Okay. Okay, let's first do this. Whoops. Rope node equals that. Dang, man. For someone who doesn't know C, I'm looking at that and I'm thinking, wow. What's wrong? Why are you highlighted? Oh, probably because I'm not returning anything. If I returns, yeah, okay, there we go. Okay, so we've got this, and now we're going, well, come on. Now we're going to say node data equals data, node left equals null, node right equals null, and node length equals, I guess what is this thing? Sterlen? Yeah. Data. That's narrowing conversion from unsigned long to signed type int. I guess a pointer is an unsigned long. How big is an unsigned long? How big is an unsigned long? Let's, here's this. Print f percent I size of unsigned long. What's wrong here? Oh, this? I just want the size. Here, what is that? Fail. Already I failed. Shouldn't have failed. Oh my gosh. What? In new rope. First defined here. Collect error. Oh my gosh. What? First defined here. Well, yeah, what's the problem? Rope dir. Multiple definition of new rope node. What are you talking about? First defined here. Yeah, I know. That's where it's defined. And then I'm fine. Don't even include the rope. I'm not trying to find that out right now. There, it's 8. An unsigned long is 8. That's huge. That's 8 bytes, isn't it? Cannot find. Oh, okay. Yeah, I don't know what I'm doing. I don't know what I'm doing. Okay. Uh, Sterling. Sure. Sure. This can be an unsigned long. Okay, that's fine. What the heck is my issue here? I don't, I have no idea what I'm doing. Uh, yeah, here. Yes, this one. Why is this not working? Holy crow. What the heck? What's wrong? This may be why people don't do C. Okay, so I got this include, and that's awesome. And I got this include. C make rope dirt. You know what I have to. Here, let's get out of Zen mode for a second. What is my CMake file? Oh, that's why. Okay. Because it's including main, and then main is including rope, and rope is then included again a second time. Okay, I want. Can I? You can. Can I do this? Can I say set? Is there like unity? Okay, fine. Well, what we're gonna do, I don't want to deal with that, so we'll just get rid of that. There, this should work now. If I go here, this should work. Yeah, that should work. Okay, so this is fine. This is fine, and everything's fine. Okay, so now I got this, and I can say, rope node root equals null. That's good. Um, but then I'm going to say create new. What the heck? What the heck is going on here? New rope node. That's what I called it. New rope node. It's there. Now I'm in Zen mode. This is okay. New rope node. And then I need to say hello to this. I don't need the length. I don't need the length at all. Here. Is it going to let me convert to global function? Convert to raw string literal. Okay, so this is kind of interesting. Okay, let's get rid of this length because we don't need it. We're going to use it. Okay, so that should be fine, right? And then come on, printf uh, percent. Ah, perfect. Except no, I'm not doing size of rope node. Come on, I'm doing the root length. Did this properly calculate the length for me? 5. So it totally can do it. It totally can do it. I'm excited about that. Okay, so we're basically there. Again, okay, what are these things I have to do to it? The binary tree. This says I need a reference count. That might not be necessary. Okay, collect leaves. Let's do I really want to do the collect leaves? No, I don't want to do the collect leaves right now. Rebalancing, I will probably leave that to the very end. Index, this should be interesting. Um, We got the algorithm here, so that's good. So let's just let's do it. Okay, so we're gonna go char. Um, I can uh, get k from the node and the unsigned long index. Well, sure. Yep, because everything is an unsigned long. Yeah, that's gonna make for huge strings. Oh well, doesn't matter. Okay, so look at this. I would really like this to not actually give me so many suggestions. I'm trying to learn here. How can I learn if you keep telling me how to do things? Okay, so, and here, it's right here. So basically, to retrieve the ith character, we begin a recursive search from the root node. That's a little funky. For example, let's just go to example. To find the character at I equals 10, start the root node, A. Find that 22 is greater than 10 and there is a left child, so go to the left child, B. Okay, so we got to start. Okay, yeah, so okay, basically, if it's greater than, yeah, okay. So if index is greater, oh, see, that's equal to node length. Sure. No, we want to do greater. Yeah, we just want to do greater. So if you're bigger than the node length, um, then you're going to return get. Yeah, you know what? This is not get char. What am I talking about? I want to. Does this have a nice renaming? Get index. Okay. Perfect. Return get index node left index. Okay. What's the problem here? Expression is implicitly converted to incompatible pointer type rope node. What are you talking about? Expression of type struct rope node is implicitly converted to incompatible pointer type rope node. Oh, hold on. Can I do this? Can I do this? Do I do this? Come on, what do I do? I don't know what the problem is there. What's going on? Well, I mean, I know what the problem is. A struct rope. Is there a precedence issue? Ugh. Well, I don't know how to fix that. What do you want to tell me? Inspection. Edit inspection. Edit the. I don't care. I don't freaking. I don't know what's the freaking else. Return get index, and this is going to be node right, but now it's going to be now we subtract the weight of what we're actually looking at. Yeah. So we're going to go index minus node length. If it's bigger, we just jump to the left. If it's smaller, if index is smaller, this is wrong. This is wrong. Is that what they have? Start index minus weight. No, that's not what they have. Okay, index minus node.length, because node.length is the weight. So basically, in this scenario, if you did 10 and you're at B, 10 is less than B. 10 is greater than 10 is less than B. 10 is greater than 9. So you take 10 minus 9. And you pass along the 1. But you only do that if the index you want is greater than the node's weight. Because I messed this up. So if it's greater than the node length, then this is what you're going to get right. And you're going to go index minus node length. Otherwise, if it's less than, you're just going to go to the left and keep the index the same. Okay, there, that's fine. And now I just got to figure out this stupid thing. Oh, and then I have to, but now I need a base case. Okay, finally 2 is greater than 1, but there is no left child, so the character at index 1 of the short string is the answer, and this is a 1-based index. Okay. So this is, if it's greater than, you're going to go to the right. Otherwise, else if node left is not null. So if you have a left child, then you're going to go there. And this is when it doesn't have a left child. We're less than the length. So now we're going to return node data, and this is index, and we're 1 indexing it, so we're going to go -1. That's right. That's totally right. That's it. What's going on? Parameter node can be made pointer to const. Sure, we can do that. And I'm guessing this can be const as well, because we're not changing them. This is a little frustrating. Why is this? Get indexes within a cursive call chain. Well, yeah, that's what I've done. Oh my gosh, inspection, clang tidy options. What the heck? I guess there, yeah, I guess we don't really need to do that. We can just do that. This is something I have to figure out. This is where this is where we go like this, we go like this, and then we go like this. Because this is 2025, we say what the freaking heck is wrong with this? And then we let Gemini just do its thing. Whoa, it's perfectly valid. What are you talking about? Well, yeah, I'm getting this error message. I get this warning. Uh-huh. Oh, it's not the structure itself, it's how I'm using it. Uh-huh. Yeah. This means I have a pointer named something that points to a struct rope. The const keyword here applies to the pointer itself, not the rope node. What the heck? The const keyword here applies to the pointer itself, not the rope node it points to. This means that my pointer cannot be made to point to a different memory location. However, you can modify its contents. Uh-huh. You're trying to assign a pointer that can't be reassigned. What? I am? What are you talking about? I'm absolutely... Why is this a warning? How to fix it. Rope node is the receiving context. Ensure that the function or variable you're assigning to expects a struct rope node or a struct rope node const. What are you... Oh, my back is making this unbearable. Um, oh, okay. Um, okay, well, it didn't care about me not removing this. Well, I don't understand. So this tells me that const of rope node const a mismatch in constness of the pointer versus... Okay, how would I fix this? Oh no, wait a second. Okay, hold on. Let me ask it something else. Does this mean I have to specify struct everywhere? I thought the type def allowed me to simply use rope node. Talk to me, Gemini. Oh, it's a common point of confusion, is it? You're absolutely correct. Well then, the fact that you're getting a warning related to pointer types is a separate issue. Oh, the type def is working. You can indeed declare variables. The warning you're seeing is specifically about the constness of the pointer. And the constantness of the data being pointed to has nothing to do with whether you use struct or, okay, both are valid ways. Okay. So do I have to, do I have to do this then? I mean, that's, I don't know what I'm trying to do. Okay. All right. 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 Let me think about this. What's going on here? Oh, I still don't understand. This isn't const. Expression of type struct rope node is implicitly converted to incompatible type rope node. Struct rope node. I can do this. I can add the const. See, that doesn't. All right, I give up. There's something. Okay, so here's what I got. Fix it, please. Come on, Gemini. Do your thing. So what are you doing? You might be calling getIndex with a pointer that is defined as struct rope node const, for example. Meaning it promises not to modify the rope node it receives, and my root pointer is a pointer that cannot be reassigned, but could in theory, is to explicitly cast your struct to a const when calling the function. What would, huh? Get indexes within a recursive call chain. Well, that's the whole point. It's a recursive thing. What don't you like about that? I don't understand that. Why does it care? Okay. So the node itself was constant, which means I'm not changing it. But the right is not constant. I see. So this struct rope node is not a const struct rope node because the node is const. Its left is also const. No, maybe that's not the case. Interesting. Okay, well now we can now we can okay, printf. We're going to go root. No, this time we're going to go get index root, and the index is going to be 2. Okay, and this wants me to say C. Okay, so this should do. I guess it's 0 indexed, so it'll be L. It should be L. Ha! It's totally borked. Uh, what's wrong? Oh, it's because I didn't know how to do what? Function has 2 parameters. Oh my goodness. Oh my word. It's because I got another bracket there. Okay. Okay. Uh, E. E. So the index, oh yeah. Okay. So by its nature, a rope is 1 based indexed. Right. Right. Whoops. Right, because we do this. We do the data index minus 1. Okay. So we gotta get index call that works. Now we gotta sort of build up. We kind of have to build up a rope node, but I think we're gonna do that next time. I'm getting hungry and my back hurts. Anyway, this was my experiment in live streaming coding thing. So maybe this worked and maybe it didn't. Well, hopefully if well, at least hopefully I helped you fall asleep if that was your reason for watching, because let's be honest, seeing me struggle with C is probably not that entertaining. But okay, that is it. Thanks. Have a nice day. I'm gonna stop this. Oh, it's been an hour. Okay, bye.